Significant figures are a very important topic in any type of science, including chemistry. And this is because whenever you're doing an experiment, you're making lots of measurements. And measurements have a certain amount of uncertainty associated with them. And depending on what tools, how precise the tools are that you're using to make these measurements, the amount of uncertainty changes. So just as an example, we have some graduated cylinders. And I want you to focus on this graduated cylinder on the left and this graduated cylinder on the right. So this first graduated cylinder has a tick mark for every 10 milliliters. So when we're measuring out, so these two graduated cylinders have the same amount of volume in them. And when we're measuring them out in this larger graduated cylinder, there is a little bit more uncertainty associated with this measurement because there's not quite as many tick marks on the graduated cylinder. So when we're making this measurement, we would say, okay, we definitely have somewhere between 10 and 20 milliliters. And then we have to guess on the second digit. So we could say something like, we have maybe 12 milliliters, okay? But when we're looking at this smaller graduated cylinder where there's a tick mark for every milliliter, now we definitely know we have between 11 and 12 milliliters, but it looks like we have slightly less than 12 milliliters. So here we would say that we have maybe 11.9 milliliters. Okay, so what this illustrates is that for this first graduated cylinder, we have one certain digit and one uncertain digit. So this second digit has uncertainty associated with it, but both of these digits are significant. For this smaller graduated cylinder, our first two digits are certain, our second digit is uncertain. So for this measurement, we have three significant figures. So the more significant figures you have, the more accurately you know your measurement. So we'll say this first one has 2 sig figs, and the second one has 3 sig figs. Okay, so now we're ready to do some of these problems. So for this first problem, we have a measurement of 0.010 meters. And you probably remember from your PowerPoint that one of the first concepts is that if you have any leading zeros before any non-zero integers, then those leading zeros are not considered significant. And this might make you feel a little bit uncomfortable especially because of this decimal point that you want to consider those to be significant. But another way that you can think about this is that we could rewrite this measurement to be 1.0 centimeters. So here you can see that we have, in this rewritten measurement, we have a 1, a decimal place, and then a 0. So zeros after a decimal place are considered significant. So when you rewrite this in centimeters rather than meters, you can easily see that there are 2 significant figures. For the second example, the only zeros in our measurement are between non-zero integers. So zeros between non-zero integers are considered significant. So for this number, 1.003 liters, all 4 of these digits are significant. So here we have 4 significant figures. Problems C and D illustrate if you have a 0 that is before the decimal place but not between non-zero integers, how you determine the significance. So let's look at this first example. So if we have 450 grams and there's no decimal place here, then what this is saying is that we knew 4 definitely, 5 was a guess, and this 0 isn't significant at all. So if we just have 450 grams written this way, then we'll say that there are 2 significant figures. However, if we have a decimal place after our 0, then now we're saying that we definitely knew our 4 and 5 digits, and this 0 has some degree of uncertainty associated with it. So here we have 3 significant figures. Okay, this last problem, E, this problem is illustrating the difference between exact numbers versus measured numbers. So remember that significant figures are important when we're measuring something, and that's because the number of significant figures is representing the degree of certainty that we know this measurement. But if you have an exact number, so let's say we have 5 people in a room, we can easily count and see that there are 1, 2, 3, 4, 5 people, and there's no uncertainty with that measurement. So this is an exact number. So basically anything that you can count is not going to have any uncertainty associated with that measurement. And so if you have an exact number, then we simply say that this number has an unlimited number of significant figures.